adding rational expressions with and subtracting rational expressions, and then solving rational equations. Hopefully you did your homework last time, and you know that when we are looking at multiplying or dividing, there's factoring involved. There's going to be factoring involved today too. Now, step 1 says use what you know about finding least common multiples of polynomials to find the least common denominator. Do you remember how to find the least common denominator of something? In other words, if you're adding fractions, let's say you were adding 1/4 plus 3/20. What's the common denominator here? It's what? So the common denominator is 4. Guys, when we talk about common denominator, what we're talking about is what number will both of these numbers go into? Not will go into them, what will they go into? In other words, it's the biggest combination. It's the least they have in common. It's the biggest combination of all of them. If we were to do this, we would say that this is 4 is 2 times 2. This is 2 times 2 times 5, isn't it? So we would take the combination of those that covers everything. This right here has both the 2 times 2, doesn't it? And then the 5. So if we took that number, it would cover both 20 and 4, wouldn't it? So the common denominator here would be 20. Okay? So how would we add those together is we would say, all right, we got 1/4 here and 3/20 here. What do I need to multiply this by? In other words, this already has the factors of 2 times 2. What is it missing from that common denominator to make it match? In other words, what do we have to multiply it by? What? 5. So I would have to multiply top and bottom by 5 to make them match. So we would have 5/20 plus 3/20. And now we know that they have a common denominator. In other words, the same number in the denominator. Once we have a common denominator, we can just add or subtract the numerator, can't we? So what would this end up being? It would be 5 plus 3 is what? 8. So we would combine this, 8/20, which would then reduce to what? I can pull, 4 out of this and a 4 out of this, so it'd be 2/5, wouldn't it? Okay? Now, we're not going to be doing anything that simple this morning. We're actually going to be doing this with rational expressions. In other words, we're going to look at this instead. X plus 12 over 4x minus 16 plus x plus 4 over 2x minus 8. So this is what I'm talking about when I say we're going to have to factor first. So we need to factor the denominators to see what we're working with. All right? So what can I factor 4x minus 16 into? What can I pull out of both 4x and 16, guys? 4. So if I pull out a 4, what do I end up with? Yeah. X minus 4. So now that's what that looks like. Now, what about 2x minus 8? 2. And what do I end up with inside? X minus 4. Now we find our common denominator. So what are all the factors that we need to account for here? Guys, what do we have here? See, this is the problem. If you can't do this part, you can't do this. What do we have in both of them here? We have an x minus 4, don't we? And then we have a 2 and a 4. Which one's the bigger? In other words, does this account for this, or does this account for that? It's the other way around, guys. I think the phrase least common denominator is what throws you because you're thinking smaller. Really, when we're talking about common denominator, we're taking the most of everything. So if you think about 4 as 2 times 2, how many 2's do we have to account for? 2 of them, right? That would be the 4. And then we have...
interruption. This is for students who don't have an on-campus history class this semester, or for our Excel students who take history at Excel. Please go to the auditorium at this time for your picture. Thank you.
All right, so we've got a 4, and we've got this, don't we? Yes? If that is your phone, you can put that away. Right? Do you have your phone? Okay, all right. You just keep looking down at something in your lap. It makes me a little, okay. Makes me a little paranoid. It's good. Go ahead. All right, so 4 is big enough to account for the 2, isn't it? And then we've got this factor as well. So this really is the biggest factor between the 2, isn't it? So do you see that the common denominator is going to be what? We need a 4, and we need an x minus 4. Questions? All right, now we've got to apply that to everything. So we're going to take x plus 12. We're going to go ahead and put that here. We're going to put x plus 4. And yes, I am putting them in parentheses for a reason. Because now we have to compare what's in our denominator with what's up here in our common denominator and decide if we need to multiply by anything. All right, guys, so do I need to adjust this first piece here? Do I need to adjust this at all? Look at this, look at this. What do you notice about these? They're the same, aren't they? So do I need to multiply this by anything? Okay, so now look at this and look at this. Do I need to multiply this by anything? What? 2. So that's what we do. We multiply by 2 over 2. Now we're just going to wrap it all up together, okay? So let's do this. We've got x plus 12. And I'm going to go ahead and put them together in the numerator. And then we've got this 2 that we're going to distribute into both of these. So 2 times x gives us 2x. And 2 times 4 gives me 8. Might as well do that while I'm working on it. And then we had the common denominator. 4 times x minus 4. Okay? So now, finish it out. X plus 2x is 3x, and 12 plus 8 is 20. Over 4 times x minus 4. And guys, that's it. So did we do it? It says, did we find the least common denominator? Yep, we did. Least common denominator. Find the equivalent fractions. Yep, sure did. Substitute the equivalent fractions with the least common denominator. We kind of add the numerators. Yep, we did that here. Combine like terms. We did that here. So do you see the process? It's really a lot of steps for something that basically says, find the common denominator, adjust everything to match the common denominator, and then add the numerator together. Okay? Let's look at another one. Let's try one here. Take a look and try this guy. First thing I want you to do is I want you to find the common denominator. Figure out what the common denominator is if we've got 3xy and 8x. Look at the numbers first. What's the common denominator for 3 and 8? 24. Good. What about the x's and the y's? Do we need an x? Will that account for both of those x's? Yeah, each one of them has one x in it. Do we need a y? Yes, we do. If one of them has a y, we need a y. If one of them has an x, we need an x. If one of them had an x squared, we'd have to do x squared. It is the biggest amount of each thing there, okay? I wish they'd call it greatest common denominator, but it isn't. The common denominator means the greatest number of each factor there. We have at least one x, bing. We have at least one y, so we need that as well. We have a 3 and an 8. They don't have anything that matches, so we need at least one of each of those too, don't we? That's where the 24 comes from. Do you get the idea now? So 24xy is my common denominator. So now you have to adjust. So I want you to take the 3 over 3xy, the 7 over 8x, and figure out what you got to multiply each one of those by. What do I need to multiply the 3 over 3xy by? Good. 8, right? It's the thing in that common denominator it doesn't have. What about the 8x? What do I need to multiply this one by to make it match? How do I get this to match this? Not just a 3. It has an x.
3y.
Ah, 3y. So now we have everything over 24xy. 8 times 3 is, and then 7 times 3y, 21y. Can we add those together? Can we add those together? No, we can't, can we? Okay, so then we're done. That is our answer. This one's for homework. How we doing so far? Okay? All right. What about if they have polynomial denominators? Polynomial denominators, same thing. I actually think tend to think it's a little bit easier. So let's look at this guy right here. Polynomial denominator. What is my common denominator? Treat this like it's one thing. Treat this like it's one thing. Do we need an x plus 3 in our denominator? Do we have an x plus 3 in our denominator? Then we need one. What else is in the denominator that we need one of? Yes, x plus 5. Some of y'all are getting this. Good. So that's my common denominator. So now, I want you to figure out how to adjust both of those. What happens? 4 over x plus 3. What does it need to be multiplied by? 1 over x plus 5. What does it need to be multiplied by, top and bottom? Chase? What do I need to multiply the 4 over x plus 3 by? Good. Allie? What do I need to multiply the 1 over x plus 5 by? Good. All right, Wyatt. What is this going to turn into? Think about it as distribution, right? Because it's being multiplied. 4x plus what? 4 times 5. Which is what? 20? Okay. And, Caden, what's this guy going to turn into right here? You're just going to distribute this in. What's 1 times x plus 3? Okay. And it's all going to be over what, Addison? Good. All right, Amy. What's the numerator going to end up being? Good. All over x plus 3 times x plus 5. Okay. This other one is homework for you to do. Now, what about this guy right here? Just very quickly. Will that guy factor? Yes, it is the difference of two squares. What will it factor into? Okay, so you better make sure that you factor it first before you find your common denominator, because look what you see. What do you notice about here and here? Yeah, it's in there, isn't it? So what's my common denominator going to be for this one? X minus 3 and x plus 3. Okay. The second half of our lesson is going to be, I think these are actually back. We need to look at solving rational equations. This, believe it or not, I think is actually easier than what we just did. It starts the same. It starts with find the common denominator. So it can't be too bad. We know what that is. So what is the common denominator for this example problem here? Dylan, what's the common denominator? We got a 4. What else do we need? Okay. 4 times x plus 1. Now, look what it says, though. It doesn't say adjust them both. What does it say in step 2? Multiply through. Guys, if we want to solve this, we want to get it out of fractional form, don't we? Anybody like to deal with fractions when you're solving? No, me either. So we're going to get rid of the fractions by multiplying through by the least common denominator. That means everything gets multiplied by it. So we are literally going to take this common denominator, 4 times x plus 1, and multiply it by x minus 8 over x plus 1. And then we're going to take 5 over 4 and multiply it by 4 times x plus 1. Now I want you to see why we're going to do that. What do you see here and here? What do you see there and there? Those are common factors, aren't they? So what happens to common factors? They cancel out. They eliminate each other. Do you see we have common factors on the other side of that equal sign too? What can I mark out on the other side? The 4. Boom. Fraction's gone, guys. So now we have 4 times x minus 8 equals 5 times x plus 1. Now all we have to do is distribute. So what do I get out of 4 times x minus 8? Yep, 4x minus 32. And then the 5 times x plus 1. Thank you. 5x plus 5. Now we just have to solve this by getting all the x's to one side and all the numbers to the other. So we are going to solve this by subtracting 4x from both sides. That gives me negative 32 equals x plus 5. And then I bet you know what you need to do at this point. What do I need to do now? Subtract 5. Okay, so this leaves us with negative 37 equals x. Now guys, notice what the last step says. The last step says check for extraneous solutions, right? Extraneous roots. What that means is we need to make sure that if we take this negative 37 and plug it in right here, that's not going to go to 0. So what we do technically is usually take this over to the side and say x plus 1 equals 0. Cannot be 0, can it? So what can x not be? Negative 1. So is this an extraneous solution? Is it negative 1? No. So it's not going to make it go to 0, is it? So as long as these don't match, As long as matched, they're not extraneous, which means this is the solution. Okay? We got a little time left, so let's try another couple examples here. First thing you got to do is find the common denominator. Is there anything in the denominator we need to factor? No. So what is my common denominator then? What are the factor groups I need? Yeah. We need a 3 and we need p minus 6. Good. Now all we need to do is multiply both sides by that. Multiply all the way through. 3 times p minus 6 times p plus 4 over 3. 13 over p minus 6 times 3 times p minus 6. In other words, if you're not seeing it, this right here is in both of these places, isn't it? So what goes away? 3 there, and okay. So now all we have to do is distribute out. We've got p minus 6 times p plus 4. That we have to multiply out, don't we? FOIL it. So what do we get? P squared plus 4p minus 6p minus 24. And then 3 times 13 is... Okay. So we get p squared minus 2p minus 24 equals 39. We're not done because we still haven't found the solution, have we? Do you remember how we find the solution to a quadratic like this? Everything on one side, factor, and set the factors equal to 0. So we need to move that 39 over, don't we? So we're going to subtract 39 from both sides. So this is going to equal 0. So now we have p squared minus 2p minus what? What is that, 63? All right, what does that factor into? Okay, somebody said -9 and +7, correct? For some of y'all, this is going to be the hardest part. What multiplies to give me -63 that adds up to -2? That would be -9 and +7, correct? So now we take, and if it takes you drawing that little crisscross, do it. Whatever it takes to get you to think about those numbers together. So now we take p minus 9 and p plus 7. So p is 9 and p is what? Okay, so now we need to check for extraneous solutions. What is my only extraneous solution from up here? P cannot be what here? 6. Are either of those 6? So are any of them extraneous? Okay, so we have no extraneous. So these are the solutions. Okay? All right. Last example, and then we're done. Anybody have any questions so far? Please ask if you have questions. Are we getting this? Can we find the common denominator? Do you feel better about that now? Can you factor? Then it's just algebra. Once you adjust the common denominator, it's just regular algebra, isn't it? Solving an equation and then checking solutions. All right, so let's do this guy. There was a K at the end of that, by the way, just so you know. It's k squared minus 2k over there. All right, so we've got to do a little factoring, don't we? What does k squared minus 2k factor into? K times what? Yep. This is still k, and this is still going to be k times k minus 2. All right. So what is my common denominator here? k, so they've all got a k. This one's got a k minus 2. The last one's got a k minus 2. This one's going to need it, isn't it? All right, so now we take that and multiply all the way through. K times k minus 2 times 3k minus 15 over k times k minus 2 minus 1 over k times k minus 2, k plus 6 over k times k minus 2, k times k minus 2. All right. Once you get it written out, it takes longer to write it out than it does to actually work the problem. It's just make sure you don't skip anything. So what can we cross out in the first one? Yeah. What about in the second part? Okay. And then the last one, all of that. So in the first part, we're left with just 3k minus 15 minus 1 times k minus 2 equals k plus 6. Now all we have to do is work this out. Do a little distribution. So 3k minus 15 minus k plus 2. And I would like to go ahead and subtract those away. Does that make sense? Because I know it's going to have to equal 0 at the end anyway, isn't it? You got to get it equal to 0. So now let's find all of our common factors. 3k minus k is what? Yeah, 1k or k. Negative 15 plus 2 minus 6. Yep, negative 19 equals 0. Well, this one ought to be easy. What is k equal to? 19. Now we have to check for extraneous solutions. We had k could not be 0, and k minus 2 could not be 0, so k cannot be 2. Those are my extraneous solutions. Does this match either one of those? So, are any of them we can throw them away? Nope. So my solution is that. Okay. We've got 5 minutes and we've got a last example to do. The only reason I'm doing this one last example is I want you to see, because so far we haven't had any order. Let's do subtracting with polynomials. Same deal, guys. Only difference is flip one more page. I think I got them out of order somehow. It went backwards. Yeah, let's do subtracting first and then we'll do solving. Subtracting is the same thing, guys. It's the same process, except this time we're going to subtract what's next. So we're still going to be finding what? Common denominator. So help me out here. What is the common denominator for this? What do I need to do here first? What do I need to do here first? Factor. What will it factor into? Good. X plus 4, x minus 4. What is the common denominator for this thing then? Yes. X plus 4, x minus 4. See? You're getting it. So now we need to adjust this. We have x over x plus 4 minus, and this is what I like to do. I like to turn it into a plus negative. You'll figure out why in just a second, because otherwise you forget to do things like distribute. All right, so what do I need to multiply by top and bottom here? What does that guy need? All right, y'all are getting this. X minus 4. What does the second half need? Does it need anything? It matches, doesn't it? So it doesn't need anything, so it's already adjusted. So I get this times this, so we distribute this in. What do I get from that? Yep, x squared minus 4x, and then plus a negative 6x, so minus 6x, all over yeah. So finish up and tell me, what does this thing end up being? X squared minus what? Okay. Now, I will warn you to go ahead and factor that if you can, because you need to make sure you're not going to be able to factor something out after the fact. So x times x minus 10, right? There are no common factors, so we'll just leave it like this. Let's look at one more of those, and then we'll talk about solving. I want you to find the common denominator. So first thing you're going to have to do is we're going to have to factor this. What does x squared minus 4 factor into? Yep. X plus 2, x minus 2. What does 3x plus 6 factor into? What can I pull out of 3x plus 6? 3. What's left? All right, so figure out what is my common denominator. What are all the factors that I need between those two? I need an x plus 2. I need an x minus 2. What else is there to account for? The 3. So that's the whole common denominator, isn't it? All right, so now let's adjust. We've got 2x over x plus 2x minus 2. Negative 2 over 3 times x plus 2. So I need to multiply both of these by something. So take a second to figure out what I multiply the top by, the first one by, top and bottom. And then the second one. Jocelyn, what do I multiply the first one by, top and bottom? 3. Good. All right. Cameron, what do I multiply the second one, top and bottom, by? I got an x plus 2. Okay. All right. So 3 times 2x. 6x, right? And then I got to take this negative 2 and multiply it into both of those. So I get plus or minus 2x, right? And then what? Plus 4. All over 3 times x plus 2, x minus 2. So now we just have to clean it up. 6x minus 2x is... Yep, and then I'm going to finish up by factoring that out to make sure. What can I pull out of both of those? So I have 4 times x plus 1. I'm just going to put that over there. And then okay? Next two ones will be for you. The bottom two say homework. You need to do those two as part of your homework, okay? Try those two. All right. So now, how many solutions have we? So let's look at this last one and see where, I'm going to work through it very quickly because y'all know I want you to see where the extraneous solutions come into play. So we have a common denominator. This becomes what? X plus 2, x minus 2. So my common denominator is x plus 2, x minus 2. Yes? Okay. So let's just work this through. X plus 2, x minus 2 times x over x plus 2. 1, 2. All right. X plus 2 goes away here. X minus 2 goes away here. And both go away there. So I'm left with distributing x squared minus 2x. I'm going to distribute this -1 into both of these. Minus x minus 2 equals 8. I'm going to go ahead and subtract 8 from both sides. So that equals 0. And I end up with x squared minus 3x minus 10 equals 0. Okay? Now I need to factor that. So that factors into x minus 5 and x plus 2. So x equals 5 and x equals -2. However, we need to check for extraneous. Extraneous solutions come from my common denominator, don't they? X cannot be -2. X cannot be 2. Uh-oh. What do you notice here and here? They are the same. Guess what that means about the solution x equals -2? It is extraneous. We need to throw it away. Because these match, we're going to throw it out. So my solutions are only x equals 5. Do you see where you can have an extraneous solution? You just always need to compare what you got to what can't be 0, right? Okay, the last 2 problems are homework. Now, when you get back next time, I think actually there are 5 of those. You've got some on the next page. So you got 5 of these. By my count, you've got about 8 homework problems. All right? So make sure your other homework's done. Make sure this is done. Next time we are going to do some reviewing to help make sure we know what we're doing with this. And this is it for the lessons. This was 2 lessons, guys. Talk about a short amount of material. So next time we're reviewing. Okay. So next time, guys, we're reviewing, which means next week, guess what? You have another test. So if you were not happy with your test this last time, you got a chance to do better, don't you? As far as test corrections go, you've got 1 week, but from the time that I tell you, which will probably, I'll probably get the rest of them graded today for 3rd block, which means starting tomorrow, you'll be able to come in and do test corrections. And the video is online, okay? That's the notes, and I'm going to set it inside. Some of them we do, if you watch the notes, some of them we did, and the ones we didn't do, you'll have to do. All right, so when we go down there, when they call for us in a few minutes, when we go down there, you need to do, because I think these are the most important to what we're doing, you need to be able to do this, all right?